We're going to do the same thing with alcohols and other functional groups that we've done with the other functional groups. So we're going to look at the nomenclature of them, we're going to look at the drying isomers of them, although that's not really going to be a big thing with alcohols because you already know how to do that. And then eventually we're going to look at the chemistry of them. And we're going to focus on alcohols, but then throw in a couple of other functional groups as we go through. So obviously, the thing we're going to do is tweak our nomenclature, following the same basic principles. One of the things is the name ends in OL. Now, we're going to have to fix that just a little bit. Position of the alcohol functional group has to get the lowest number, and you might be thinking, what if, and we'll get to some of those, but not a lot of those, and the good news is we're not really going to have to worry about it too much. So if you had this, where an alcohol group is on carbon number 1, obviously that's going to be carbon number 1. You're going to number it from that end. 2 is that you're going to call it a propane 1-ol. An older system of nomenclature that is still very much in use would call it a 1-propanol, but this is the more modern, and that's the one we're going to try and use as much as we can. If it's on carbon number 2 on a 4-carbon chain, then it's a butane 2-ol. And I know that it looks like it should be pronounced butan 2-ol, but it's butane 2-ol because that's what you'd call it. If you had 2 functional groups, in the same way that you would have a dimethyl or a dichloro, now you have a diol. So same principles apply, butane 1,3-diol, and you may be wondering why the E mysteriously came back. Basically what it comes down to is if those numbers weren't there, would you want the E or not? Yeah, in this case you would, previous cases, no. Now, the reason that we have it as a kind of keep part of that butane or propane is because you could have a carbon-carbon double bond in the same chain as an alcohol, and then we want to change the ending for both. How do we do that? So we're not going to do that. So if you were busy scribbling that down and writing it, you can stop. I should have said that earlier, sorry. But then you would call something an ene-ol because a carbon-carbon double bond and an alcohol functional group. We could take exactly the same thing and throw it into other functional groups. Now, by the way, the ones with the little star, asterisk, or whatever it's called, we're not going to do the nomenclature of it, so it's more just for your interest, and I built a table with that many rows and thought I should fill them. So we're going to do the nomenclature of ketones, we're going to do the nomenclature of carboxylic acids. I know there's a couple of other functional groups that aren't on there, like ethers and esters. Esters we're going to do a little bit, but not too much. Amines we're not going to do, and aldehydes, I've got a star on both sides because A, we're not going to do them, B, nobody actually uses this because ending a word with AL and ending a word with OL sound a lot alike, so it leads to confusion. So there's a kind of a different, very common system of nomenclature that people use for aldehydes. Okay, some examples. If you had a 4-carbon ketone, we would call that butane 2-one. Now, below that I've just got it called butanone because here's the deal with that one. In order for it to get a ketone, where you've got a carbon double bond oxygen and a carbon on either side, on a 4-carbon ketone, it has to be at carbon number 2. So there's really no other option. So you don't need the number there, but I encourage you to put it in. That way you're building the habits. If you had a, that is not a 4-carbon thing. That is a 2,4,6-carbon thing. That is a hexane 2,4-dione. I'll have to thank my proofreader when I get back. So don't write down that name. It is a hexane 2,4-dione. You could have a dione on a butane, but it would not be 6 carbons long. And then if we were to try one of those other functional groups, propanoic acid, so I have an acid functional group on a propane. Now an acid functional group, carboxylic acid, has to be at the absolute end of a chain, so we generally don't need the numbers for that. To go into a different functional group that we're not really going to need to worry about, so you don't need to, hexane 1,5-diamine. Okay, so that's kind of a big, ugly looking thing with two amine groups. Hopefully I've got the right carbon count on that. Okay, what about? You could call it hexanal, but as I mentioned before, right, then it does start to sound a little bit familiar, or sorry, a little bit confusing, a little bit the same as a hexanol. And then what if you had two functional groups, so maybe a carboxylic acid and an alcohol? Well, you'd start doing things like this. So that would be a hydroxy acid. And if you look at some cosmetics, you'll see alpha hydroxy acids in some cosmetics. The funny thing about amines is that nitrogen can be in the middle of the chain. It doesn't have to be a group. So if you had something like that, where if you follow the longest continuous carbon chain, or if you look at all the carbons, nitrogen seems to be in the middle, and a bunch of things are coming off of that. So then you would identify the carbons that are attached to the nitrogen by NN. We're not going to worry about it. We're not going to do that. But if you ever see something like that, that's what's going on. Hopefully this was short. I tried to keep it brief, but I always do, and I still run into 15 minutes. But the nomenclature for alcohols, ketones, carboxylic acids. Okay. We're not going to do the nomenclature of those other ones, and the other ones that we do, like esters, we'll kind of do in class in connection to a lab. And then we don't need to worry about the multiple functional groups other than, say, a chlorine group on any of those things. And then, yeah, okay, we're not going to worry about that. And yeah, so that's kind of where we're at. This was just the nomenclature of. And then I suppose if I could ask you to do isomers, but we didn't really talk about that. But you know how to do isomers. Anyway, talk to you another time.